Hello, everyone. So welcome to this session number 10. I think this is the session number 10 of, yeah, I think this is the session 10 of my DevLab sessions. So last class, in our last DevLabs, we started working on C#. I kind of went, discussed a little bit about methods. But today, what I want to do is, I want to step back a little bit, and I want to talk about the basic syntax of, you know, uh, the basic syntax and basically operators and things that you can practice with. And that's what I'm going to do. Maybe this session can go for about 1 hour, or maybe a little bit more. Or maybe we can, look for some of the challenges, some of the questions that we can see through the internet and try to solve some of them. Okay, cool. Right, so let me share my screen. If you want to follow along, you can click this link. This is not Unity C#, right? If you are new to this, this is not Unity C#, but instead this is going to be, just C#, right? Okay, so I've posted the link here. Let me just post it again. I'm going to post the link in Discord as well. So this is the platform, the thing that we used last class in our last DevLabs to, basically to code stuff. All right, let me just give me a second. All right, so we talked about different things, like we talked about variables in our last session. And also we talked about classes and methods. But, talking about classes and methods the very first time, it might be a little bit overwhelming. So I'm hoping to do, step back a little bit and focus on things that we can do inside of the main method, right? So we're not going to be creating any, any instances. We're not going to be creating any, I don't know, like, no classes, no methods, but we are focusing mainly on the syntax. Right. Okay. So now let's do something cool. You can follow along with me if you open this link right here. Right. This link I put in Discord as well. And it's right here in the, as a part in the chat as well. Okay. So operators. So when it comes to operators, you might know what operators are. Basically, we use a lot of operators in mathematics, right? So what are some of the operators? For an example, if you want to add two values, we basically have the addition, right? I'm not sure whether this is visible, so I'm just going to type it like this, addition. So usually the addition symbol is denoted by the plus sign, right? Basic things that we know. And then subtraction, right? Subtraction is given by a minus sign. And then we have multiplication. In computer programming and in computer things, we don't really use X for multiplication. Instead, we use a star to multiply the two things, right? And then division. So when it comes to division, like you write a dash and two dots by the side, a division symbol. But instead of that, in programming and also in computer science, we use the backslash. I don't know whether it's the backslash or the forward slash. Whatever, the backslash. This is what we use to divide. And then we have two more things that we can discuss. One is called the modulus. Not two, it's actually three. One is called the modulus. And the modulus is denoted by a percentage sign, right? I'm going to show you what modulus is, right? So usually modulus is the remainder of a division. Remainder of a division. All right, so I have a question. Right. So if you divide 10 by 3, what would be the modulus? You divide 10 by 3, what is the modulus of that? Pretty cool. That is 1, right? So usually we use modulus. So there are like some good applications where we use modulus. Maybe we can, I can think of one, and maybe we can use modulus to actually code something and see. Okay, then we have another operator called increment operator. So in the increment operator, this is how we write the increment operator. We use a plus sign. Usually what happens is we cannot say 1 plus plus. We can say 1 plus plus, but usually what happens here is that it increases the value by 1, right? I'll show you what this, I'll show you all of this. Then there's another one called decrement. Decrement, we use minus to say, hey, this is a decrement. So basically in decrement, what happens is it decreases the value of a variable by just 1. Okay, so now let's use these operators, right? Let's use these operators and let's see what we can come up with. Okay, apart from that, there are some assignment operators that we can think of. That we can use in C#. But basically, let's just do some exercises and let's see. All right, so I'm going to delete all of this, and here I'm going to use that console.writeLine, right? So here, just type console.writeLine. The case is pretty much sensitive here. So make sure that C is capital, W is capital, and L is capital, console.writeLine. And what we're going to do is we're going to do something with 2 of this, right? Okay, so basically if you want to add 2 of these numbers, you just put a plus button right here. This is it's pretty simple, right? But I'm going to explain this anyway. Right, so if you put plus 5 right here, basically it will just give you the summation of it, right? 15. And if you put a minus right here and click run, the answer will be 5, right? And also if you put a modulus, what would be the answer here? If you put a modulus here, what would be the answer? Question. What is the output? Hey, don't put a modulus and check the output and put it here, right? Just without trying it, what would be the result? 10 modulus 5. No answer. What can this be? 10 modulus 5. 0, exactly. Because if you divide 10 by 5, there are no remainders. That means the value is going to be 0, right? So how do you actually check whether a given value is, odd or even? For an example, imagine I input a number, right? I input a number and then basically I need to check whether it's either an odd number or an even number. So one easiest way to check that is to divide this by 2, right? If you divide this by 2, any number, if you divide it by 2, that means the remainder is going to be either 0 or 1. It can be either 0 or 1, right? So if the remainder is 0, that means it is a even value. Yasmiji has a question.
Yes. So my question is, I haven't able to use this remainder, the modular so far, but what's the purpose of using this? Why do we have to know the remainder of division?
Yes. So sometimes, so basically the remainder is pretty much similar to this. For an example, you have to divide something by 2, and let's just say that you divide 10 by 3. So usually the value will be 3.33333333, right? but this will not give you the remainder, right? So why do we need remainder? That is one of the use cases that I shared, right? You can check whether this is divisible by a given value. Now, for an example, imagine that you want to, that you are working on a counter, and every 10 steps, you want to reset the counter, right? So imagine that you're getting a, you're getting an input number, right? For an example, 1, and then you divide it by 10, and basically the remainder of that is 1, right? So now you know that this is not a value that is divisible by 10. So usually we use the modulus sign to check whether this number is properly divisible, right? So usually if it is divisible, then the remainder is going to be 0. So there are some use cases, a good use cases doesn't come to my mind, but just make sure, just keep in mind that we have this operator. There is an operator where we can get the remainder out of it. That is why I said we have, like, one of the easiest use cases is to check whether a number is odd or even. That's pretty simple. We just basically have to divide it by 2. There are like multiple ways that we can do it, but of course, using a modulus is also a similar way of doing it, right? Okay, I'll look for some good use cases, but we'll be using, and like, if you try to divide this by 2, sometimes you will not be getting the correct answer, right? So basically, like, 10 minus 10 divisible by 2, or how does it work? No, it doesn't work that way. So basically, you have to divide it, and getting a remainder might be a little bit hassle if you try to do it with the 4 basic operators. So using the modulus might be the best way for that. Okay, so just like that, we can talk about the minus, the division operator. If you divide 10 by 2, the value is going to be 5. Cool. Okay. Now we're going to talk about something else. We can talk about assignment operators, right? So we talked about variables in our last lab session, but let's just, go ahead and create a new integer variable, right? So before this console.writeLine, I'm going to create an integer variable, int. I'm just going to call it number, and I'm going to give a value for this, which is number 10, right? So if you just, over here, when I say console.writeLine, rather than this, if I put number right here, right, console.writeLine, and just put number. And if I press run, basically you'll be see number 10, because it will basically just print out the number 10. Now let's talk about the increment and decrement operators, right? So over here, what I'm going to do is I'm just going to say number plus plus and put a semicolon, right? So this might feel a little bit off, right? But still, we can use it like this. So this is like one of the frequent ways of incrementing things, right? We might have seen this in loops, in for loops as well. But what happens here is that it takes the number value and it increments by just 1. Okay. Now, so this itself doesn't have a value. It has a value. I'll show you what it does, right? Okay. Now I'm going to click run. And the value that you will see here is number 11. Why? Because in line number 10, the number's value is 10. And after line number 12, right here, you can see the value increments just by 1. And now the value of number is 11, right? So when you print out the number right here, it just prints out 11. Okay. Similarly, if I just type minus, 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 and if I click run, the value is going to be 9. Does that make sense? All good? You can put an emoji, right? So that way I know that you're following, right? If you have any questions, feel free to put it in the chat. All good? Awesome. Okay, now I have a question. What if I do it like this? console.writeLine number plus plus. Don't try this, without trying this, tell me the value that you can see here. 11. Okay. Others? Anybody else would like to guess? What can be the value? 11. Okay. Awesome. All right. So 11. But let's try and see. I'm going to click this run button. Let me open up my mouse highlighter. All right. So I'm going to click this run button. And now you can see, oh my God, this is not 11. It's 10. What the hell? Right? Okay. So, oops. Okay. Right. Now, let me just show you something real cool, right? So over here, you can see that I typed console.writeLine number plus plus. I'm just going to say console.writeLine again. I'm just going to write this again, console.writeLine. And here I'm going to just type number, right? Not number plus plus, but basically just number. So in this case, all right, so over here also, this is 10, then this is also should be 10, right? So that is the instinct that we get. But when I run it, you can see that the first line is, I don't know why it runs like this. Let me just run it again. There you go. The first number over here, you can see it as 10, but the second one, you can see it as 11. So what happens here is that when you use something like this, when you use an operator, the value of this is basically going to be the number, right? Plus plus is something that you do. It's not a value, right? Plus plus is, it just says increment. But before incrementing, the console.writeLine will look at the number, right? The value of the number is 10, and it just prints it out, right? So after printing, or basically it's after printing, it just runs this operation. What happens here is that the value of the number increments itself, right? So after the print, it will increment itself. And then in line number 13, the value of the number is going to be 11, because right at the end of this, the number's value has incremented by just 1. Does that make sense? Does that make sense? So you had to put plus plus before console.writeLine in order to add plus 1 to 10. Exactly, right? You got it, right? So look at this. I'm going to remove this plus plus. And instead, I'm going to put plus plus right here. Plus plus number, right? Plus plus number. So now when I do it, now you can see, aha, there you go. So first of all, when the console tries to, understand what's here, it just says, hey, plus plus number. So that means add a 1 to the number and give me the value. Before it says, hey, what is the number? Okay, then add 1 to that. So the flow is a little bit different. So it's better if you can understand what's happening in this increment. So you might, if you look, if you just go through some other codes, sometimes you might see things like this and you might feel like, okay, what is this? I haven't seen this before. And it's like, it's alien to me. So now you know what this is, right? Now you know what an increment is, and now you know what an increment that you do before the actual variable. So basically, if you say plus plus something, that means it adds 1 to that and then, process it. If you say something plus plus, then it will just take that value and then increments it. All right. I believe that makes sense. And now we can go to the next. Okay, so plus plus and minus minus basically gives you the, it just basically gives, it just increments or decrements just by 1. What we can do is, if you want to increment this by, let's say 2, right? If you want to do something like that, then what you can do is, should you do this plus 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 plus, right? I'm not sure whether it's possible. Let me see whether it's possible. Yeah, it is not. This doesn't work, right? So if you want to add, if you want to increment this by 1, you can put plus plus. But if you want to increment this by 2, no. So instead of doing this, what you can do is you can say number plus equal 2 and put a semicolon. We need a semicolon, right? Number plus equal to. So this is similar to this one. Number equals number plus 2. So the increment, it equaled, it was equivalent for this to this. Number equals number plus 1 is equivalent to number plus plus. So as I told you last week, when we are thinking of, when we are like doing programming, and if there is a mathematical expression, always start with the right hand side, right? So now here you can see the number, the value of number is 10. So you just visualize 10 right here. 10 plus 1 equals 11. And now you change the value of the number to 11. Okay, right. So I'm going to remove this, and I'm just going to keep it like this. So basically this, what it does is it just gets the value of the number, adds 2 to that, and change the value of the number to the final one, right? So if I click run, the value of this should be 12. There you go. Okay, so just like that, you can try with all the other 4 operators. Not 4, like you can use all the 5 operators. You can say number minus equals to, or number multiply equals to. Basically, this will multiply the same number by 2. So now in this case, if you run this, the value of this is going to be 20, because the value of the number is 10. You multiply that by 2, and this is what you get, right? Awesome. Okay. Now we have some other types of operators as well. There are some, AND operators, OR operators, and bit shift operators, which might be a little bit overwhelming for you. So I'm not going to discuss about it. So let's go ahead and do some maths, right? Let's just go ahead and do some maths, and just look at some of the mathematical expressions that we have already. In C#, we have access to something called math, right? So let's do some mathematical operations and see what we can come up with. Okay. So here, let me just remove this. I'm going to remove the number and this one as well. So inside of this, I'm going to say console.writeLine. So instead of number, I'm going to say math dot max, open and close parentheses. I can say 1, 9. I'm not sure whether this works with the math library. Let me just run and see whether it works. It works. Okay. So in Unity, you might get, instead of math, you might get something called mathf, right? So don't worry. Yeah, it says mathf. But here in C#, you have the math library. It's a part of the system library where you can do mathematical expressions, mathematical calculations. So now you might wonder, how does this work? So basically, the max is actually a method. We discussed about methods in our last class, and this method itself has a value. It returns a value. We can talk about returning values, methods a little bit deeper in our future classes, but today it's all about expressions, operators, basic syntax. So over here, when you say math.max, the whole thing, this whole thing has a value, and that value is an integer, or maybe it can be a float value based on the input that you give, right? So the base input is that you can add 2 numbers into this divided by commas, and it will check what is the maximum value, and it will just use it, right? What are some of the use cases of using math.max, right? For an example, imagine that somebody has scored maybe for a test, right? And the maximum amount that he can take is 100 for the score. And somehow, the student has scored like, maybe some additional points has been added, things like that. Somehow the student has scored, 100. Oh no, that's not the best way. That's not a better example. But anyway, just imagine that something, if there is a value and you need to get the maximum value of it, right? So basically you can just put in two numbers and it will return whether this or this, it will return whatever the maximum value, right? So if you try to do this with conditions, you have to write if conditions, check whether this is greater than this, which might be a hassle, which can be done pretty easily by using a math expression, math.max. So similarly, we have math.min, math.min. So if you run this, this will check the minimum value out of this to you, and it will just just return number 9. Okay, so apart from that, we have some other expressions as well, mathematical expressions. If you want to take a square root of something, we have something called math.sqrt, math.square root. So these are not syntax, but these are just methods that we can reuse, right? Things that we can use in C#. So if you say math.sqrt, let's say 25, right? This will give me the square root of 25, right? Okay, so anybody who doesn't know what a square root is? Anyone who doesn't know what a square root is? Oh, you got disconnected for a second. Oh my God. But the recording is going to be there. So anyway, I'm going to be uploading the recording in about after the next hour. So don't worry about it. Okay, anybody who doesn't know what a square root is, I believe all of you know. Yeah, a square root is, I don't know how to explain this in English, but basically a square root is the, how do I explain this? I learned square root in my native language, so I'm not, I'm not particularly sure how I can explain this. Anyway, so, imagine that you multiply a number with the same number, right? For an example, 1 by 1 is 1, 2 by 2 is 4. So the square root of 4 is 2, right? 3 by 3 is 9, right? So that is the square of 3, which is 9. The square root of 9 is 3. So it's like the reverse of the square. Okay, cool. So now then there's another one called math absolute. Absolute. We call it ABS. Why do we say math.absolute? Absolute is something that makes a minus value a positive and a positive value a positive, right? So absolute means if you have any number, it can be a positive or a negative. The absolute is always positive, right? So usually we use absolutes in, I think mostly in graph applications. For an example, let me change the display. For an example, imagine you have a, like most of these absolute things work with graph, like many of the applications that I've used. So imagine you have a sine wave like this. If you don't know what a sine wave is, don't worry, right? So here everything is minus and here everything is plus. So if you absolute the whole thing, the final result is going to be something like this. That is because these things are now swapped the positions because they're not minus anymore, they're plus. So in mathematics, we use these two lines by a number to denote a, an absolute. So every time an absolute of a minus value is equal to the plus value of the same. So if I go to our compiler and if I add math.abs minus 10, right? And if I run it, the output value of this is going to be plus 10. Okay, so apart from that, there are some other methods as well. Now, for an example, we can use something called math.round, which will, now for an example, this will just round off the numbers, right? For an example, if I add 9.99f, right? If I round it off, the value of this is going to be 10. There you go. See, if I say math.round 9.19, this can be 9. Yeah, not basically floats to int. It's a kind of a way, like it turns a float to int, but it just rounds off to the to the closest whole number, right? Apart from that, I'm not sure whether these two methods are available. There is another one called math.floor. So when I say math.floor 9.99f, the value of this is still going to be 9, right? Flooring means you are taking it down. Now it looks like this. Now rounding it off. So let's just assume that this is number 10 and this is number 9, and I have 9.99. So if you round it off, it will be rounded to 10. 9.19 will be rounded off to 9. But when I say floor, right? When I say floor, it will flow down to the minimum, to the previous whole number, right? So this is flooring. So similarly, if you floor this thing will also get floored to number 9. And then there is another one called ceil, C-E-I-L, which will take any number to the next whole number, right? For an example, if I say math.ceil 9.19, the value of this is going to be, seems like they don't have that. Yeah, let me check. C# math ceil. Oh, ceiling, C-E-I-L-I-N-G. All right. C-E-I-L-I-N-G. Ceiling, math.ceiling. It's pretty simple, right? Ceiling and floor. Ceiling and floor. Okay, so 9.19 of math, like it happens for a very smaller number. 9.0009. If you try to ceil this, it still goes to 10. This is really close to 9. You can still see this, but ceiling will always take you to the other one. Awesome. Okay, so that is it about mathematical expressions, right? So we'll be using a lot of mathematical expressions in Unity, right? We want to calculate things. We want to multiply things by something else, right? We'll be doing some vector mathematics, vector calculations. There's a lot of calculations that we'll be doing. So we'll be using a lot of mathematical expressions and mathematical methods like ceiling, flooring, maximum, minimum. Then there are things like random, and usually Unity doesn't have, it doesn't support the random value that is given by C#. But if you go to C# is something that is invented by Microsoft. Microsoft actually is the developer of C#. I'm not sure whether C was a part of Microsoft, but anyway, so there was a language called C. There is a language called C, which is still being used for a lot of electronics development. And then there is another language called C++, which is kind of like an extended version of C. And then Microsoft built a new language back in the day called C#. It's more like an object-oriented, pretty simple language compared to C++. So as you can see right here, if you go to, if you just search for C# documentation, it will take you to the Microsoft documentation, because these guys are the, people who actually built it. And you can see that, C# is actually a part of .NET. So sometimes when you install applications, it tries to install .NET runtime and stuff like that, because it's the .NET runtime that can actually compile and that I can actually, make use of C#. So you can see here, we are talking like, C# is pretty big. We're just picking things. And right now you can see there's like a lot of stuff, right? We talked about ABS. We talked about ceiling. We talked about floor. And we talked about max and min. But apart from that, you can see we have a lot of stuff. And over here, we can see math.pub. So, you don't really need to keep all of these in mind, right? Like even Albert Einstein says that, you don't really need to memorize things, right? That's why we have books, right? So just like that, you don't really need to memorize things. That is why we have documentation, right? Over here, you can see there's something called math.pub. What it does is it will return a specified number raised to the specified power. So basically, this just gives you a power. Maybe we can test this out. All right, let's say math.pow, and it is requesting two numbers. Don't worry what this double means. Basically, double is a float. Double is also a float. It's just a number, right? Double is a float. Usually we use double to represent bigger values. Not going to talk about this, but anyway, just consider this as a float. So if I go to a compiler, right, for an example, 2 to the power 3 should be 8, right? 2 to the power 3 is 8. So if I run it, I will get 8. 2 to the power 3, right? 10 to the power 3 is 1000, right? So just like that, you can, rather than multiplying this by multiple times, you can just use math.power to get the power of, two numbers. So always this has to be the one that we are getting the power, and this has to be the raise, right? Okay, so you can look some of them, just check out the documentation, and based on your applications, we might need to use many of them. Okay, so yeah, there is something called mathf as well. I'm not sure what is the difference between. I think mathf uses float instead of double. Yeah, there you go. See, mathf uses float instead of double. Just because we talked about double, you might feel, oh, okay, what is the difference between double and float? So just to give you a very small idea, when we talk about variables, as I told you, variables are data, they store values, right? So where do they actually store values, right? For an example, if I say float x equals 10, this x and the value 10 has to be stored in your computer. Usually this is stored in the RAM, right? So when you run a program, these things are saved in the RAM, right? So in the RAM, if you consider a RAM as a cupboard, right? This cupboard is divided into separate cells. Let's just assume that these are cells. So a float, I think a float has its size, right? If you say float, a float can take up, let's say, 4 chunks of this cell. Not 4, the actual value is not 4, I think it's 32 bits. Don't worry about the bits also. In the computer, a computer cannot store values as a number. A computer has to store values in zeros and ones, right? So these zeros and ones take up different cell spaces. And a float usually, let's just assume that a float takes 4 spaces, right? So if I take 4 spaces, the maximum that this can show is 1, 1, 1, 1. Usually this is, in decimal, it's number 16. So just like that, usually I think the float uses 32 bits, just like that, it uses 32 cells. And a floating point number can never go to infinity, right? You can see that it can never be infinity. It can never do that, right? Of course, it can show you billions and trillions. That is possible, based on the number of bits, but it cannot go to the infinity, right? Okay, but there is a way that, if you search for max float max, You can see here that it shows you something like what is float max. Yeah, it says 3.40 multiplied by 10 to the power 38. So it's a huge number, right? It is a huge number. So if you want to go more than that, that is where we use double, right? So if your calculations use more than the value that the floats give, you have to use double, right? So if you're using double, usually you you use D rather than F. When you say D, it's going to be considered as a double. So you cannot say float X equals 9.99 D, because when you say D, it's going to take more space. I think it's more like the double the size of the float, right? More space. You cannot take a double and put it inside a float, right? You cannot fit it in. But the other way can be done. If you say double, double X equals 10.0 F, that is possible because it's smaller, it can be fitted inside a double. Right, don't worry about many of those things. So double and float is pretty much the same, but the double can represent more values. So just like that, integers also has something called long, right? Similar to that, integers can go up to a certain value, and right after that, it has to use long. And sometimes, you might not even need to go to this level. So basically, there is another data type called short, right? So in any case, by any chance, if you meet some of these, like short instead of int or long instead of int, just don't panic. So there are things like this. Okay. Right. So now that we talked about mathematical expressions, it is the time for us to learn about conditions. Or should we talk about strings or Booleans? Yeah, let's talk about Booleans, right? Because Booleans are very much important for us to understand conditions, right? So you might have, we learned this last time as well. Boolean, usually represented as bool in C#. Bool. As I told you before, a Boolean is something that can either be true, or false, right? In that cupboard that I told you before, that cupboard, it will just take one cell, just one cell. Why? The value can either be 1 if it is true, or 0 if it is false, right? So Booleans are very important for us to understand conditions as well. But anyway, before moving into conditions, let's just see some of the expressions, some of the some of these signs that we can use in order to identify these conditions, right? So this is very cool. And before moving into any of those conditions, this is a cool practice for us to understand what's happening right here. Okay, now let's go to our compiler and let's do some, a couple of exercises, right? So first of all, I'm going to get a couple of numbers, right? These numbers are going to be just, two values. Int x equals 5 and int y equals 10, right? So imagine that I have two numbers. Now, what I'm going to do is I'm going to do a small condition, right? Not actually a condition, but see what, how these Booleans are formed, right? I don't have a Boolean variable, but I'm going to see how, not mathematical, how C# expressions or operators can result in a Boolean value, right? Okay, so here I'm just going to say console.writeLine. I'm just going to type x greater than y. Okay, I have a question. Is x greater than y? So this is the greater than sign, right? So we've learned this in our class as well. Is 5 greater than 10? No, right? If that is no, that means what would this be? Is this true or false? This is false, exactly. So when I run it, now you can see that x greater than 5 is false, right? So don't worry about the case sensitiveness over here. It just prints out false. Console.write line will just say, hey, this is false. If you change this to the other side, console.write line less than y, right? Less than y. Now this will say true, because 10 is now greater than 5, and 5 is less than 10. Okay. Then there is another expression whether we check whether these two are equal, right? So in C# we use equal sign. We use two equals, right? If I just use one equal sign, console.write line x equals y, and if I click run, it will print out 10, right? Because right here you can say x is now equal to y. That means the value of x is now equal to y. Now, for an example, if I just type another console.write line, and if I print out x, right? So here, okay, let me just run it again. So here what happens is, I don't know why it just prints it out like in just one line. But imagine we have 10 and 10 separately. So over here, what happens is the value of x will be equal to y. It will not check whether it's y, right? So here, this will just be equal to y, and it will just print the value. So the value of x is ignored because in the console write line, you reassign the value of x to y. Yeah, basically, it is not ignored. It will just change the value of x to y, and the value of y will be printed to this. It's pretty much like what we did with the plus, right? So it will do this thing. First of all, it will do the calculation or the assignment, and then it will print out the value just like this, right? So right after that, now you can see the x is not 5 anymore because you just assigned a different value. And now here it's again 10, right? So sometimes I've seen that most of you, out of curiosity, rather than checking for a condition, you'll just type x equals y. So that way it's not going to be a true or false value. Instead, it's going to be an assignment, right? Rather than a condition, rather than a check. Okay, so if I type equal, so the value of this, will this be true or false? X equal y. So if you see something like this, you can say, is x equal to y, right? This is what you can say. Is x equal to y? If you run it, you can see that it says false. Hey, this is not equal. But if I change this to 10, and if I run this, then it will say true, because those two values are similar. Okay, so let me just change this to 5 again. Okay. How do you check something is not equal to, right? So if you want to check something is not equal to something, instead of saying equal, you're going to put an exclamation mark, right? Sorry, I think a fly kind of went into my mouth. All right. Cool. X is not equal to. So when you see something like this, you'll always keep in mind, okay, x is not equal to y. So what would be the value of this? Is it equal to y or not? What if I press run? What would be the result of this? 5? No. It will never print it because this is a conditional operator, right? Yes, so Minji is correct. So the value is going to be true. Why? Because it will check whether x is not equal to y. Sorry. So over here, you can see that the 5 is not equal to 10. So if I run it, okay, so if I run it, you can see that the resultant of this is true. So basically what this does here is it checks whether y and x are not equal. Because they are not equal, the value of this is going to be true, right? So when I say 10 and 10, now this will check for not equality, right? So if I run this, even if these are equal, the value of this is going to be false, which is pretty cool, right? It's pretty cool. Okay. So now this operator or this expression is really cool because we'll be using this a lot. Let me just show you something. I'm just going to say, console.writeLine true. And if I run this, you will get true. Don't worry about these two variables, right? I'm just saying console.writeLine true. This is not a text. Basically, this is a Boolean, right? It just says true. What if I put an exclamation mark in front of true? I just put an exclamation mark in front of true. And now if I run it, now the value is going to be false, right? So it's the inverse of this, right? So if I say x equal y, right? So this is true because if I run this, you can see that x and y are equal. So this expression gives you a true value. And if I say, if I just cover it up with a, if I cover it up with just two parentheses and put an exclamation here, right? Now, if I run this, you can see that gives me false, right? Because inside of this is going to be true. And if you cover it up and if you put an exclamation, it's going to give you the inverse. Okay, does this make sense? Does it make sense? So basically the console WriteLine bracket outputs Boolean by default. Not really. It will just print out whatever the value that you have here. It can be an integer, it can be a string, it can be a Boolean. So when you bracket it, basically it will just, the BODMAS thing that we discussed, BODMAS, the same principle can be added here as well, right? So when brackets has the higher priority. So if you bracket it out, first of all, it will check this. So this is exactly similar to this, right? So this is going to be exactly similar to, let's say, console.WriteLine. Yeah, console.WriteLine. This is going to be exclamation. Okay, exclamation. Within brackets, this is going to be true. Right? So exclamation true is equal to false. All right. Okay. So now we talked about different types of Boolean different types of operators that gives us Boolean values. Now let's combine some of them, right? Let's combine some of them and see what the answer is, right? Okay. Right. So let's do something. Let's just figure out something really cool. Okay, so over here, imagine that I have a battery, plus and minus. Da da da. Da da da. I have a bulb. Right, so this is a bulb which lights up. It's a light. And then I have one switch here and another switch here. Okay, I'm going to say this switch as A and this switch as B. If I want this light to be turned up, right? If I have A, B, and let me say, if, this is the light, right? Both of the switches are off. will the light be on or off? It's off, right? So I can say 0, right? 1 is switched on and B is off. What will be this value? It is off, right? If you check the other way around, it is still off because, you know, the electricity cannot go through. Only if both of these are turned on, then only the value of this is going to be on, right? Does that make sense? Both of these switches has to be turned on in order for light. So this is called a logic. You know, you might have heard of this before. This is known as a logic gate, right? In computers, you'll have a lot of logic gates. You have all of these electronic equipment, like inside all of these electronic equipments, you have, you have processors, right? You have processors that are going from, different, there's like a lot of pins. And if you zoom in with a magnifier, inside of this, you'll have logic gates, right? Logic gates. So these are not like physically representative like this. These are, generated by using electronical components, transistors, to be honest. This is known a logic gate, and this logic is known as AND, A and D. So you can see that an AND operator, if you have two things, right? If the AND needs to be true, then both of these needs to be true. That is known as AND operation, right? Okay, let's just see an example. Over here, I'm going to say 5 and 10. And then I'm going to take another two numbers, A equals 1 and int B equals 5. Right? Okay, so here, now we talked about just one operation, right? We talked about just one operation. But now let's combine two operations and let's check it like this, right? Like this one. Okay, so my first condition is going to be to check whether x is greater than y. So over here, I'm going to say x is less than y. Right? So what is the value of this? Is it true or false? X is less than y, true or false? It's true. It is true, right? And now what I'm going to do is I'm going to give AND. You use AND sign and symbol, right? So this is, consider this as one of those switches, one switch, right? And then I'm going to take another switch. I'm going to check whether B is greater than A. Is this true? Is this true? B is greater than true. Exactly. So now if I run this, now you'll see the value of this is going to be true. Why? X is less than y. This is true. This is true. And here you go. If you change this, B is equal to A. So this is true, but this is false, right? So if I run it, now you can see that the value is going to be, oh, sorry, my bad. This needs to be equal. B is equal to A. So it checks two conditions. Is B equal to A and X is less than Y, right? So you can see here, I combined two conditions together to check whether it's true or false. True or false. Does this make sense? Does it make sense? Right? So multiple combinations. So in programming languages, these are not limited to just two, right? So in logic gates, oh my God, okay. In logic gates, we discuss about, rather than two gates, we can talk about hundreds of conditions. So if you have something like this, all of these switches need to be turned on in order for this to be true, right? So this whole thing is known as an AND logic, or in C# programming, we just use AND, right? So you might have seen, one of the examples in game development is to check conditions. For an example, imagine that I have I have a small player, right? So if you press W, A, S, and D, right, this guy can move forward, it can jump, it can, just go here, or it can crouch, many things. So imagine, he's just flying up. He's just jumped up, and his velocity is V, which is greater than 0. And he is not grounded, is grounded, right? Is grounded, is grounded false. You check whether it's not in the ground, right? Like this. Oh, and maybe is W pressed, right? So there can be multiple conditions that you need to check in order to perform something, right? So in such cases, we use these types of this operator and, right? So you can have like multiple conditions like and A less than B and oops, B and X greater than A. So you can do it like this. So every time that you have something like this, C# automatically considered this as one condition, this as another condition, this as another condition, and this as another condition. If I run this, there's a higher chance that this is going to be a false, right? There's a higher chance this is going to be a false. Like, in conditions, it will first check whether this condition is true or false. And if all of these are and, if the first one is false, then all of this is going to be false, right? If anything is false, all the AND operations are going to be false because, the circuit is broken. Okay, so now we talked about the AND operation. So now let's do another cool exercise, right? Okay, just look at this one. Ah, my bad. Okay. Oops. Anyway, let me just draw it again. All right, A and B. My bad again. Sorry about it. It should be like this. Okay, so if I tell this, if I talk, if I, name this A and B, A, B, light. Okay, if A is off and B is off, what will be the, whether is the light going to be turned on or off? Both of these switches are off. They are off, right? If A is on, B is off, what would be the value here? A is on, B is off, right? Will the light be turned on or not? It is turned on, exactly. Why? Because the electricity can go through, go through this, because this is now turned off, right? Can go through this, and which is pretty cool. It's pretty cool. So just like that, if A is off and B is on, what would be the value? 1, right? Now, if A is on, B is on, both of them are on. Anyway, it can just find out any path out of this. The value is going to be 1, right? So this logic is known as OR logic, OR. right? Either A or B, whatever. It has two pathways. Basically you have like, so if this is your house, right? If this is your house and you have a puddle here with a path to the store, and then you have another path where you can go to the store. So you can go either through this or this, right? If you have like a path with two puddles, right? If you want to go from if you want to go from your home to the store, basically you have to go on top of both of the puddles. But here you can use either this path or this path. This is known as OR, right? So sometimes you might need OR symbols, right? You need to check whether this happens or whether that happens. Now, for an example, if we go to this exercise, right? Let's do this. If X is greater than Y, or how to write the OR symbol, we use two lines like this, right? It is the, usually this is the button with the forward slash. I think it's right over here. It's above the return button, above the enter button in your keyboard. You need to type two two lines, right? X is greater than Y, or I can say A is less than B, right? X is greater than Y, or A is less than B. So what would be the output of this? Now we know that X is greater than Y. This is false, right? A is less than B. This is true. What would be the output of this? Yes, this is going to be true because either this or this is true, right? This is pretty cool. So now you understood, and similar to the AND operation, you can combine multiple OR operations as well. And the best part is you can combine multiple AND and OR operations, all of them together. Okay, you can combine all of them together. So it's going to be more like, condition 1 and condition 2, and then you can do a bracket, or condition 2, yeah, I'm just going to add another and here, condition 2 and condition 3, or like there's a lot of things that you can do, or maybe like another couple of conditions, like condition 4 and condition 5, right? So you can combine all of them together and say, or you can say 1 equals 0, equals 0. So it will check either this or this, or I can say and 1 equals 0. So the whole thing is going to be false because there is something that checks whether 1 is equal to 0. This is false. That means everything is, the whole thing is now false. So you can combine this, you can combine these operators together to take a true or a false output. Okay, does it make sense? All good? So this now leads to conditional statements. So up until now, we did not talk about conditional statements. We just got the value out of it and we just printed it out. That's it. Now we're going to talk about conditional statements. I'm going to talk about conditional statements, and I'm going to give a basic introduction to conditional statements, and I'm going to end this, and I'm going to continue next week. Okay, conditional statements. So we talked about X, Y, X is greater than Y. So these are the main operations that we use: greater than, less than, AND operation, OR operation. We check the inverse of something, and we check the equality, equal sign, or we check not the inverse of equality, right? Not equal to. So all of these things combined we can create conditional statements. So in conditional statements, this is how the syntax looks like. right? The basic conditional statement, right? It's pretty simple, very similar to English. If open and close parentheses, here, this is going to be the condition. So what is a condition? So all this time, right before all of this time, these are the conditions, right? It can be just one condition or it can be multiple conditions, right? So when we say conditional statements, we check this. If condition, right? If condition, so this condition has to be true, right? This must be true. If this is not true, the if condition, whatever that you put inside the if condition will not work, right? Okay, let me just clarify. If we have the condition, make sure that the condition is within parentheses, and then we open curly bracket, close curly bracket. So this is a code block, right? So here, everything here will be executed if the condition is true only, right? If the condition is true, whatever that you put inside these two right after the condition will be executed. If not, nothing will happen. Now let's see an example, right? So we talked about console.read write line, but we did not talk about console.read. I think we talked about it a little bit, but let's do something cool. Okay, I'm going to say int x equals console dot read line, open and close. So usually this console dot read line will open up a space for us, so we can just type something and press enter. So the value is going to be that value. We talked about this a little bit briefly in our previous class. Okay, so here I'm going to say if x is greater than 75, if x is greater than 75, I can say console dot write line. I can say you are passed. Right. Does it make sense? Does this script make sense? Is it confusing? If it is confusing, please, feel free to ask the question, right? So what happens in line number 10, don't worry. Basically, it just opens up an input for us, so we can type anything and press enter. So whenever we press enter, it's going to execute from here, right? So let's just run it and see how it works. So if I run it, you can see now it's running. Oh, sorry, my bad. Okay, let me see how we can use console read line int. We have a user input. Let me see how I can take this to an integer. Yeah, okay. There is a way that we can do it. It might be a little bit overwhelming. Let me just type this. Don't worry what I have here. Basically, what it does is whatever the input that we take, it's going to be converted. That's going to be assigned to the value, right? So don't worry about what I'm writing right now. Convert dot in, I think it's called to int 32 console dot read. Don't worry what I add here. Just imagine that I can put any input here and that input is taken, right? Okay. So now this is requesting an input. Let me just type 40. I'm going to type 40 and press enter. And you can see the program ended, but nothing happened, right? It doesn't say you are passed. That is because the value of x is now 40 and nothing worked here, right? It checked whether it's greater than 75 and that's it, right? Okay. Now, if I run it again, And if I say 89 and press enter, it says you are passed. That is because right after this, it will check the condition, right? 89 is greater than 75. So inside of this, this is going to be true. Because that is true, this will be printed out. Okay, so I have a question. I'm going to copy this and I'm going to put it right here and say you are failed. Right? And I'm going to run this. And I'm going to type 98 out of 100. Okay, I have a question. Guess what the answer would be? What would be the output? Nobody? You can just guess it, you know? Aha, there you go. Right, okay. So Patricia, yes, it says passed, but Miji is correct. It says you are passed, then you are failed. That is because when I run this condition, it will check the condition, right? And it will run it. I'm not sure. Oh, I think I pressed, let me just put 98 again here and press enter. And there you go. It first prints out your passed because the condition is true. And over here, it just prints anyway, right? Even if you have failed or not, it will just print anyway, because this thing is just one code block, right? So it will just print this because, you know, it's a 98, the condition fulfills it, right? But at the same time, it will just print this out as well, because you are not checking the inverse of it. You're not checking whether, you know, if you are not, if X is not greater than 75, we are not checking this, right? So we can do that by putting something called else right after this. So this is the syntax, right? If, open and close parentheses. So you put an exclamation. We can do that way as well, right? But before that, what we can do is, if we have only two conditions, right? One condition is to check whether it's greater than 75, and the other condition needs to check the inverse of it, right? So if X greater than 75, do this, else, and then you open and close another set of curly brackets. So this is the syntax, right? If this, it's basically if this, then do this, else do this. So if I copy, if I cut this from here and paste it here, now if I run it, and now if I type 98, this will just say you're passed. That's it, right? Else, that means if you are not greater than 75, if I run it, and over here, if I say 67, oops, whoa. Let me run it again. Okay, if I type 67 and press enter, now it says you are failed, because it comes to this conditional statement. It will check whether X is greater than 75. 67 is not greater than 75. So the condition inside of this is false. It's not true, right? Only if it is true, it will print line number 14. If it is not. So basically, it's kind of an inverse. If it is not, then it will print this one. Okay. So now what we can do is we can do some sort of a grading system, right? If you are greater than 75, and also there is another one that I forgot, we can check a condition by something like this, greater than or equal to 75, or less than or equal. So this is something that I missed before. We can use this to check greater than or equal. So, you know, if you remember in high school, we learned this, you know, greater than or equal, less than or equal. If you remember in mathematics, we learned something like this. This thing, you know, there is no way that we can represent this in you know, from all the characters in the keyboard. So this is, you know, we just say greater than or equal, or less than or equal, right? So these are the two things that I missed before. Okay, so over here we can say if x is greater than or equal to 75, I can say you got an A, because now, yeah, you got an A because you're like, more than 75. Now, instead of saying else, what I'm going to do is I'm going to say else if, right? It's more like, hey, if your value is greater than 75, do this. Else, right? If not, x is greater than 65. So there is another condition only if this is not enough, right? Else if, open parenthesis, x is, let's say, greater than or equal to 65, then I can say you got a B, right? So just like that, I can say else if x is greater than or equal to, let's say, 45, then I can, just try to understand the pattern. It's pretty simple. You can see, it's pretty, very organized. It's divided into different, chunks, right? Else if x is greater than 70, greater than 45, then I can say console dot right line, you gotta be C, right? Now I can say else, you didn't even get an A, or you didn't even get a B, you didn't even get a C, then you're failed, right? Now I can say console.write line, you are failed. Everybody, everyone who's less than 45 are failed, right? For an example, let's now go through a number, right? 55. First of all, 55 checks whether it's greater than 45. No, then this is not considered. Is 55 greater than 65? No, then this is not considered as well. Else, now it checks, hey, is 55 greater than 45? Yes. Then it will just print this out. You got a C, and that's pretty much it, right? So let's just run it and see what happens. I'm going to run it, and let's put a number. Let me just put a random, 68. You got a B. I'm going to run it again. And over here, I'm going to say 32. You are failed, right? So maybe another number, maybe 89. You got an A. Oops, sorry, I don't know why I pressed it. There you go, you got an A. So now this is the structure of the conditional statements, right? So we just use one conditional statement here. As I told you, we talked about Boolean, and through Boolean, we talked how we can combine different statements together. So, if you are in Unity, if you are building Unity applications, you'll be, most probably you'll be adding more than one condition in some cases, right? So this is the whole structure. If, else, if, else, right? So usually you use if and else if you have just one condition and you check the else or the inverse of it, right? Or if you have multiple conditions that you want to put in together, like this one, you can use else if, right? So with that, I'm going to end the session. So in our next C# lab, I'm hoping to extend this to learn like more things like switch operators, switch case, and then we can go to loops, and then we can think about arrays. There's a lot of that we can do. I'm going to cover up all of this in multiple lab sessions. So I have all of these recordings, and these recordings are going to be helpful for me. If anybody asks, hey, I don't know this, then I can just share the recording. It's pretty cool. Okay, I also shared a, if you are familiar, if you just look at this one right here, I shared a cheat sheet, right? If you download this, it just gives you some information. I'll take my weekend and I'll upload another cheat sheet. putting together all of the things that we discussed today. And also there is another, thing like this. Maybe after all of the C# classes are over, then we can go to this and we can try doing these, things. We can discuss about them, right? So it's going to be a discussion session rather than class, right? All right. So thank you very much, everybody, for joining. Even after a short notice, I forgot to put a notice right at the start of the week. Thank you very much. All right. So yeah, Miji has a question.
Do you have some time for short question?
Sorry?
Do you have some time to answer a very short question?
Yeah. Please go ahead.
Yeah. Okay. Because when we go back to the coding, you started writing console read line and then you got an error and then you had to convert to into 32. Would you be able to explain that?
Yeah. So this is called casting, or this is called converting the values.
Right.
So usually console.read line, this will give me a string value.
Ah,
right?
okay.
Okay,
that makes sense.
So
a
string value is, I cannot directly add it to an integer, so I had to convert it to an integer. You can see convert dot to int32. Don't worry about this because in Unity you will not be able to use this. We have different things. We have different methods to do it, right? But this is something that we can do.
Okay, great. Thank you.
All right, everyone. Have a nice day.
Bye.
Bye-bye. Bye-bye.